This is equal to 13.97. This is equal to 14. Therefore, the mass of the molasses that can be poured into each mold is 14 kilograms. Example 3. An open metal bucket is in the shape of a frustum of a cone, mounted on a hollow cylinder base, made of the same metallic sheet. See figure. The diameters of two circular ends of the bucket are 45 centimeters and 25 centimeters. The total height of the bucket is 40 centimeters, and that of the cylindrical base is 6 centimeters. Find the area of the metallic sheet used to make the bucket, where we do not take into account the handle of the bucket. Also, find the volume of water the bucket can hold. Take pi equals 22/7. Answer. Given that the diameters of two circular ends of the bucket are 45 centimeters and 25 centimeters. R1 equals 45/2, and R2 equals 25/2. This implies that R1 equals 22.5 centimeters, and R2 equals 12.5 centimeters. Also given that the total height of the bucket equals 40 centimeters. The height of the cylindrical base equals 6 centimeters, which includes the height of the base. So, the height of the frustum of the cone equals 40 minus 6 centimeters equals 34 centimeters. Therefore, the slant height of the frustum L equals square root of h square plus R1 minus R2 square, where R1 equals 22.5 centimeters, R2 equals 12.5 centimeters, and h equals 34 centimeters. So L equals square root of 34 square plus 22.5 minus 12.5 square centimeters equals square root of 34 square plus 10 square equals 35.44 centimeters. The area of metallic sheet used equals curved surface of frustum of cone plus area of circular base plus curved surface area of cylinder equals pi into 35.44 into 22.5 plus 12.5 plus pi into 12.5 square plus 2 pi into 12.5 into 6 equals 22/7 into 1240.4 plus 156.25 plus 150 centimeters square equals 4860.9 centimeters square. Now, the volume of water that the bucket can hold, also known as the capacity of the bucket, equals pi into h/3 into R1 square plus R2 square plus R1 into R2 equals 22/7 into 34/3 into 22.5 square plus 12.5 square plus 22.5 into 12.5 centimeters cube equals 22/7 into 34/3 into 943.75 equals 33,615.48 centimeters cube equals 33.62 liters, approximate. Therefore, the volume of water that the bucket can hold is 33.62 liters. Let us see some exercise problems. A drinking glass is in the shape of a frustum of a cone, of height 14 centimeters. The diameters of its two circular ends are 4 centimeters and 2 centimeters. Find the capacity of the glass. Use pi equals 22/7. Solution. Given that height of the frustum of the cone equals 14 centimeters, the diameters of its two circular ends are 4 centimeters and 2 centimeters. Therefore, radius R1 of upper base of glass equals 4/2. This implies that R1 equals 2 centimeters. Radius R2 of lower base of glass equals 2/2. This implies that R2 equals 1 centimeters. We need to find the capacity of the glass. So, we can say that capacity of glass equals volume of frustum of cone, which is equal to 1/3 into pi into h into R1 square plus R2 square plus R1 into R2. This is equal to 1/3 into pi into h into 2 square plus 1 square plus 2 into 1. This is equal to 1/3 into 22 by 7 into 14 into 4 plus 1 plus 2. This is equal to 308 by 3. This is equal to 102 into 2 by 3 centimeters cube. Therefore, the capacity of the glass is 102 into 2 by 3 centimeters cube. A fez, the cap used by the Turks, is shaped like the frustum of a cone, if its radius on the open side is 10 centimeters, radius at the upper base is 4 centimeters, and its slant height is 15 centimeters. Find the area of material used for making 8 U pi equals 22 by 7. Solution, given that radius, R1, at lower circular end equals 10 centimeters. Radius, R2, at upper circular end equals 4 centimeters. Slant height, L, of frustum equals 15 centimeters. We need to find the area of the material used for marking it. The area of material used for making the fez is calculated as curved surface area of frustum plus area of the upper circular end. This implies that the area of material used for making the fez equals pi into R1 plus R2 into L plus pi into R2 square. On substituting the values of R1 equals 10 centimeters, R2 equals 4 centimeters, and L equals 15 centimeters, we get pi into 10 plus 4 into 15 plus pi into 4 square. This is equal to pi into 14 into 15 plus 16 into pi. This is equal to 210 pi plus 16 pi. This is equal to 226 pi. On substituting pi equals 22 by 7, we get 226 into 22 by 7. This is equal to 710 into 2 by 7. Therefore, the area of material used for making fez, the cap used by Turks, is 710 into 2 by 7 centimeters square. The slant height of a frustum of a cone is 4 centimeters, and the perimeters, or circumference, of its circular ends are 18 centimeters and 6 centimeters. Find the curved surface area of the frustum. Answer. Given that the slant height of a frustum of a cone L equals 4 centimeters. The perimeter of upper circular end of frustum equals 18 centimeters. That is, 2 pi R1 equals 18. This implies that R1 equals 9 by pi centimeters. The perimeter of lower end of frustum equals 6 centimeters. That is, 2 pi R2 equals 6. This implies that R2 equals 3 by pi centimeters. We need to find the curved surface area of the frustum. We know that curved surface area of frustum equals pi into R1 plus R2 into L. On substituting the value of R1 equals 9 by pi centimeters, R2 equals 3 by pi centimeters, and L equals 4 centimeters, we get pi into 9 by pi plus 3 by pi into 4. Taking pi as LCM, we get pi into 9 plus 3 by pi into 4. This is equal to pi into 12 by pi into 4. Cancelling pi, we get 12 into 4. This is equal to 48. Therefore, the curved surface area of the frustum is 48 centimeters square.